Okay, in this one you're asked to plot, label asymptotes, look for the y values of any local extremes, use derivatives as needed. So it turns out we are going to use the derivatives, but by saying that, I'll let you just figure out if you want to use them. Okay, I want you to consider that in the numerator, y of 0 is 0 because there's an x in the numerator, and there's no other places where the numerator is 0. In the denominator, you know this is x cubed minus 1, so your cubic is going to look like that. Right, so here's that's not even a good picture. X cubed minus 1, it looks more like that. Okay, so you know there's only one real root just because you know this function. So it has one real root at x equals 1. And so we have an asymptote at x equals 1. No other asymptotes. Okay, and we know the long-term behavior. We know the denominator is has a greater power than the numerator, so we have y equals 0 asymptote there. And if we look at x going to infinity, it's going to be positive over positive, so we're going to be out here. And if we look at the x going to negative infinity, it's going to be negative over negative, which is still positive, so we're going to be over here. And so this is really all the information we need. But you probably will feel reassured if you pick a couple points on your calculator. Well, actually, it does say y values for any local extreme, so unfortunately, if it didn't ask for that, we can just go like this, and then we just go like this, and we'd be done, right? We need to actually find the extremes. So if we have to find the extremes, then we actually have to take the derivative, unfortunately. So go ahead and do that. We're going to use the quotient rule. Bottom times the derivative of the top minus top times the derivative of the bottom. Now the saving grace for this quotient rule, as we already know, that where the derivative, the bottom isn't going to help us with making this thing equal to 0. So we only have to worry about the numerator being equal to 0. Denominator being equal to 0 helps us nothing. So it's x cubed minus 1 minus 3x cubed equals 0, which is minus 2x cubed equals 1. So let's see, x is equal to cube root of 1, negative 1/2. Okay, so I know that this is, hold on a second. Okay, you just didn't need to see that. Okay, so all I did is I took the cube root of 0.5, and I get about negative 0.7937, because it's actually the negative square root, negative cube root. And I chuck that back into y, and this is y. That's where you go to get that. But you know, you don't take negative 0.7937 and cube it, because we already know it was supposed to be the cube root of negative 0.5. So you just stick in negative 1/2 there. Negative 1/2 minus 1 is negative 3/2, but I'm getting rid of the negatives on top and bottom. 3/2 is 1.5. So this point here should be about negative cube root of 0.5, and it should be about 0.53. Okay, so that tells us this thing is going to come up a little bit before it goes back down in the rabbit hole, and then this guy looks like that. Alright, and it probably, I'll label any asymptotes fine. Asymptote is x equals 1. Anything else we need to do? Yep, I think we're good to go.